So now that we can write these polynomial functions in factored form, we're going to talk about what those factors mean. Okay, so any real number b and a polynomial in standard form. So if x minus b is a linear factor of that polynomial, so if we just take a jump back to what we did before, in these answers here, or these factored forms, x minus 5 and x plus 3 are linear factors. So in these cases, b would be 0 or 5 or negative 3. In this case, x minus 4, and x plus 3 are linear factors. So b would be 0, 4, and negative 3, just so we get kind of a bearing on what we're talking about and what our b value is. So back to this screen. So x minus b is a linear factor. And each of the previous examples had 3 linear factors. So if x minus b is a linear factor of p of x, then we can say that b is a 0 of that polynomial function. It is a value for x that makes that polynomial value 0. And b is a root of the polynomial equation p of x equals 0. So if we look back here, if we set this polynomial equal to 0, then if we plug 0 in for y, then the solutions for x, like x equals 0, 5, or negative 3, then 0, 5, and negative 3 are roots of the equation x cubed minus 2x squared minus 15x equals 0. Then these are roots of that equation. And finally, I don't like, and the other teachers don't like this, the wording of the second one. So instead of just b, we are actually going to change that to a coordinate. b0 are x-intercepts of the graph of that. So if we just look back here, if we were to graph this function, x cubed minus 2x squared minus 15x, then the points 0, 0, 5, 0, and negative 3, 0 would be x-intercepts of that graph. So 0, 5, negative 3 are zeros of that function. They are roots of this equation, and those points are x-intercepts of that graph. So that's kind of how they're all intertwined and how they are all related. And that means that the factored form can give us those things. So what we're going to do is find the zeros of these functions, and we'll talk a little bit about what multiplicity means. Multiplicity just means that a particular zero occurs more than once. That's what multiplicity means. So in this case, the zeros of these are x equals negative 2 from the first factor, 1 from the second factor, and 3 from the third factor. So those are the zeros of that function, which means the corresponding graph would have x-intercepts of negative 2, 0, 1, 0, and 3, 0. In the second one, the zeros of that function are 0, 3, and -5. And the corresponding graph would have x-intercepts at the point 0, 0, 3, 0, and -5, 0 then. Now, in both of those examples, none of those zeros occurred more than once. So in C, the first thing we're going to do is write this in factored form, just like A and B were given to us in. Now, to factor this in C, the first thing we're going to do is factor out the greatest common factor, which is x squared. And after we do that, we have x squared minus 2x minus 8. And then we look for factors of -8 that add up to -2, and they are -4 and +2. So we have our zeros. We have x equals 0, but because of this x squared, it's like that 0 occurs twice. That's what happens with this function, is that 0 occurs twice. And in class, we'll look at what happens, what does that mean on the graph. But because that 0 occurs twice, we say that that 0 has multiplicity 2. That's what we say. We say that that 0 has multiplicity 2. Because of that exponent of 2, it occurs twice. Now the other two zeros, 4 and -2, there we go, 4 and -2, since they don't have an exponent other than 1, they only occur once, so we don't say that they have multiplicity, only those that happen more than once. And finally, in D, we're going to write that in factored form by first factoring out the greatest common factor. And factors, I'm sorry, that should be 4 there. Factors of 4 that add up to -4 are -2 and -2. Well, we could rewrite that as x times x minus 2 squared. But either way, that 0, we have two zeros basically. 0 for the x and 2 for the x minus 2 factor, but that occurs twice. So we say that that 2 has multiplicity of 2 because it occurs twice. So that's the meaning of the multiplicity. And in the next video, we will take zeros of functions and write the function in standard form for those zeros.